Hi, welcome to today's learning. I would also like to wish you a happy new month. Okay, today we're gonna be looking at a topic which is actually a continuation of the previous topics that we have been learning: volume or cubic expansivity. And then I defined it as the cubic expansivity of a substance is the increase in volume per unit volume per degree rise in temperature, sorry, per degree rise in temperature. And there is a cubic expansivity. The symbol is gamma is equals to the increase in volume. That's the change in volume. This stands for change in volume, V for volume, all over per unit volume. That's the initial volume, and then per degree rising in temperature times the change in temperature T, where a change in V is equals to the change in volume. Let me write the volume as VOL, that is V1 minus V0. V0 is the initial volume of the substance of substance, and then a change in T is um, change in temperature or increase in temperature. Then gamma is the cubic expansivity. Okay. Now also our gamma is always three times of the linear expansivity. Have this in mind, and also is also two times of the area expansivity. So whichever one that is given to us, we can actually find the cubic expansivity by either multiplying by 3 if it is the linear that was given, or by 2 if it is the area that was given as well. Okay, here is a question we have. The solid A solid metal cube of size 10 cm is heated from 10 degrees Celsius to 60 degrees Celsius. First up, calculate the increase in the volume if our linear expansivity is given as 1.2 times 10 to the power of negative 5 per Kelvin. Okay, let's have this. Um, what is our change in temperature? We know that our T1 is our T0 is 10 degrees Celsius. Our T1 is what 60 degree Celsius, and then our change in T is equals to T1 minus T0, which will give us 60 minus 10, giving us what 50 degrees Celsius. That's a change in temperature. And so if you calculate the increase in volume, that means to find the change in volume. That's what we are looking for. Also, we were given our linear expansivity to be this. That means a formula I gave to you that the cubic expansivity is always the three times of the linear expansivity. So this will be 3 times the linear. That's my gamma is 3 times 1.2 times 10 to the power of negative 5. And that will give us that my gamma is equals to 3.6 times 10 to the power of negative 5 per Kelvin. Now there's one parameter which we are yet to also get before we slot into the formula that we have. That's the initial volume. The initial volume, we need to get that. Now from here, we are given what? The length of the side. The length of the side of the cube. The length is what? 10 cm. Now remember, this is a cube. Now how can we find the initial volume? Is by finding the volume of the cube. So the initial volume is equals to the volume of the cube, which is L cube. That's the volume of a cube. The volume is equals to the length to the power of 3. So that will give us what the length is what 10 to the power of 3, which will give us 1000 cm cube. That's the initial volume of the cube. Now let's slot it into the formula that we have. That's the change in volume all over the initial volume and then the change in temperature. What was our gamma? That's 3.6 times 10 to the power of negative 5 equals to what a change in V. That's what we're to look for. Change in volume. All over what's the initial volume? 1000 times what's a change in temperature? 50. I can call this all over 1 and then cross multiply. This multiplies this, right? This multiplies this. So my change in V is equals to what? 1000 times 50 times 3.6 times 10 to the power of negative 5. Let me clean off this other side of the board. So that will give me my change in volume. That's the increase in volume. 1000 times 50 will give me 50,000 times 3.6 times 10 to the power of negative 5. Okay, I will need to use my calculator here. My change in V will give me what? If I press it in the calculator, it should be giving me around 1.8 centimeter cube. 1.8 centimeter cube. This is what the change in volume should be. 1.8 centimeter cube. So the increase in volume of that cube when it was heated from 10 degrees Celsius to 60 is what? 1.8 cm cube. Alright, here's another question that we are asked to solve. A piece of brass of mass 170 kg has its temperature raised from 0 degrees Celsius to 30 degrees Celsius. Alright, calculate this increase in volume given the density of brass at 0 degrees Celsius is 8.5 times 10 to the power of 3 kilogram per meter cube, and its cubic expansivity is 5.7 times 10 to the power of negative 5 per Kelvin. Alright, let's have this. First of all, we write out the parameters that we are given to us. Here we have our mass. A mass, that's the mass of the brass, M, is equals to 170 kg. Temperature T1 is equals to T0, that's the initial temperature, is equals to 0 degrees Celsius. And our T1 is equals to what? 30 degrees Celsius. This simplifies, or this means that our change in T is equals to T1 minus T0 That's 30 minus 0 will give us what? That's 30 minus 0. That will give us 30 degrees Celsius. That's a change in temperature. All right. You asked to calculate this increase in volume. Increase in volume also means the change in volume. That's what we're asked to look for. This question is similar to the previous one, but just a slight difference. Calculate this increase in volume given the density of brass. Density, that's rho, is giving us 8.5 times 10 to the power of 3 kilogram per meter cube. Now we are given density, we were given mass. Okay, let me finish up the question. If the cubic expansivity, that's gamma, is giving us 5.7 times 10 to the power of negative 5 per Kelvin. Now here, we were not given the initial volume, but we have a change in temperature, we have a change in volume which we are to look for, we have a cubic expansivity, but we don't know about the initial volume that will enable us to solve for the change in volume. But also we were given the mass and we were given the density of the brass, and there is a relationship between volume, mass, and density. That's the density of a material is always the mass all over what? The volume. So from here I can make volume subject of formula by changing its position with the density, and that will give me that my volume is equals to the mass all over the density. Now from here I can get my initial volume of that brass material, because I know the value of the mass, which is what? 170. That's my V0 is equals to, what's my mass? 170 grams, I mean kg. And what's my density? 8.5 times 10 to the power of 3. That will give me that my V0. Dividing this by that, I should be having around um, 20 times 10 to the power of negative 3, because 170 over 8.5 will give us 20. And from the law of indices, this 10 to the power of 3 going up becomes 10 to the power of negative 3. And that will give us in standard form, that will give me 2.0 times 10 to the power of negative 2. That is the volume of the brass material. That's the initial volume. So let's lot out this into the formula we have. That's change in V, which we're to look for all over the initial volume times the change in temperature. Or is my gamma, which is the cubic expansivity, that's 5.7 times 10 to the power of negative 5, equals to what? My change in V, we don't know. That's what we are asked to solve for. All over, what's my initial volume? 2.0 times 10 to the power of negative 2, multiplied by my change in temperature, which is what? 30. Okay, let me clean up this other side of the board. Okay, here we can call this all over 1 and cross multiply. This multiplies this, while this multiplies this. That's change in V times 1 is also change in V. And that will give me 5.7 5.7 times 10 to the power of negative 5 times 2.0, that's just 2, times 10 to the power of negative 2 times what is 30. That will give me that my change in V, 5.7 times 2, that will give us 11.4. then times 30 times 10 to the power of negative 5 times 10 to the power of negative 2. Change in V will give me what? 30 times this, as the 0 will move this point to the right. 3 times 4 is 12, carry 1. 3 times 1, 3 plus 1, 4. 3 times 1, 3. That will give me 342 times 10 to the power of negative 5, 10 to the power of negative 2. Now applying the laws of indices here in these two parts, when the bases are the same and there is a multiplication sign, you add up the powers. So here will give me 342 times 10 to the power of negative 5 plus negative 2 will give me negative 7. And changing this to a standard form, move backwards 1, 2, that will give me my change in V is equals to 3.42 times 10 to the power of 2 because I moved backwards 2 times, and then times 10 to the power of negative 7. Still applying the law of indices here, that will give me that my change in V will give me 3.42. 2 plus negative 7 is something like saying 2 minus 7. That will give us negative 5 meter cube. There is my answer for that. So a change in volume is given by 3.42 times 10 to the power of negative 5 meter cube.